Hey everybody, it's Ryan with A2L Mechanical. Today we're down here at ACiQ to take like a tour of the warehouse where everything gets shipped out of, pick up an order so you get to see that, and also to talk to tech support on some of the questions that they have. And the great thing is about ACiQ is the tech support is right here. So it's nice to put faces with the names that you talk to on the phone and stuff for me, and then also to get to see kind of the day-to-day operations here when I call about questions or just getting equipment shipped to me. So stay tuned.
Here we are at ACiQ's supply warehouse. Plenty of inventory. This place is unbelievably giant with how much equipment is here. Absolutely nuts.
Technology, right?
Yep.
What do we do? Why do we do it? What's the whole point? The whole point is pretty interesting. Obviously, everybody knows the inverter side of it is using DC instead of AC, right?
Yep.
AC has one problem, and that's off and on, right? And that's what AC is good at. AC is good at being there, or it's not being there. DC is a little bit different in the sense that we can basically modulate not only the DC voltage, but we can modulate the pulses or the frequency that goes to these motors. Once we modulate the frequency, we can then control how fast the motor spins or how slow the motor spins. So that's the whole appeal to it. So all we're doing, right, in a sense, is we're taking 240 volts in, we're bringing that to power this board. That's the first step that most people don't know. Is this board is not powered by 24 volts. It doesn't even care about 24 volts. It's powered by 240.
Okay.
And then we distribute that either from there or from here over to this main board, right? Whole purpose of the main board. Why does it have all this nonsense on it, right? That's what people get all weary about, right? What is this? Liquid line. Always the liquid line. Why? For cooling purposes. Well, Jared, 105 degree doesn't seem like cooling to me. Well, if we use the suction line, it would sweat.
Yeah.
We would get water all over our components. We're not going to do that. However, the board itself gets hotter than the liquid line does, so we can always reject heat into the liquid line. Why does it get hot? Well, the answer is when we convert AC to DC, we produce a tremendous amount of heat with something called IPMs. Underneath this heat sink, which you saw over there in my office, there are those little chips that have the little white stuff still on them. Those are IPMs. They're intelligent power modules. Their job is to very quickly alternate the frequency at which is actually feeding to the compressor or to the fan. They're both IPMs. There's one for each side. So when you convert AC to DC in that manner, it produces a massive, 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 massive amount of heat. So that heat has to go somewhere. In older style units, you would see that we had a heat sink that would protrude into the unit, and you would actually be able to see, you know, the heat sink, and that's what they were using. Now they figured out they have a refrigeration cycle. It's more efficient to use the refrigeration cycle to cool the board. The board's main objective is to do a couple of things, right? Not only do we need to drive our compressor, but we need to drive our fan motor. You'll always see the, you know, W, V, U, you'll always know that's your compressor. You're gonna see the same thing for the fan, 3-phase DC fan. So not only is that the most important part, but you have a couple of other things that's actually pretty easy to break down, right? You have your reversing valve, which is 240 volts to the valve. You have your pressure sensors, right? So pressure switches, just thinking about it in a normal sense, right? These pressure switches open and close on low pressure or high pressure. They also will have your thermistors. So you'll have all your thermistors. You have your outdoor thermistor, you have your coil thermistor, you have your TP, which is your discharge thermistor. That's mostly a safety, and all of that data feeding into the board. The other thing that feeds into the board, about pretty much the final thing, is going to be your EEV, which usually will be a 5-wire or a 6-wire.
Yeah.
Probably find it hidden somewhere in here. We'll find it probably right inside of there somewhere. But we're gonna have an outdoor EEV. A solenoid down there. There's our reverse valve. Our EEV apparently is hidden. Can't even see it really from here.
Probably gonna,
Do you see it back there?
do not. 'Cause a lot of times they're right here on the front.
Yeah, normally they like sit right on
here.
top of that.
Yeah.
But either way, you will have your EEV, and that'll be the last thing that you have to power.
Is the EEV?
Is the EEV. So that'll open and close depending on what you have. I'm trying to see if they labeled it here.
So we should be off
I've
of.
already pulled it off. Oh, did I drop it in there? Maybe I did when I pulled the board out. You also have your crankcase heater. That's in there too for defrost. You have your pan heater. Outside of that, there's really not much left inside of there. It's pretty much, those are really the only other components. Where I put them. But you'll see your high voltage comes in.
Yeah.
And then outside of that, there's really not much more you can test outside.
So these are our sensors?
Oh, EEV is going to be on the front board. That's what it is. It's right there.
Okay.
So they moved it to the front board. You can see it used to be here.
Okay.
EVs.
Yeah.
So now it's on the front board. I remember they moved that now.
Okay.
So you'll have that. You'll have a couple other things that go into the front board. When in doubt, double check your plate on top of it.
Yeah.
So we can go here and we can see like our reversing valve comes off of this, right? We can also see our pressure sensor comes off of it. Our EEV comes off of it. So this all comes off the 24 volt board. And then this board communicates with this S wire up to this board.
Okay.
So if you actually see, our voltage comes in here, and then voltage comes down, 240 volts comes down L1 in, and then L2 in. So that's what's actually powering our board. Sometimes you'll actually see this physically jumped, right? You'll see a little jumper on some of the diagrams, but it looks like in this case, they just kept it off there.
Okay.
Now, that's kind of how they did that for this, and that's why our solenoid valve, our reversing valve side, that's why it's 240 volts and it's not like 24 volts. We don't have 24 volts to use. I mean, we have DC voltage we could use, but they just had 240 available, so they just used the 240 that's actually in the unit.
Okay.
That's why most people... This is how you connect it. You can see all the wiring diagrams here. You can see your furnace. You can see where you plug in the sensors. But I'll show you what the board looks like. And I'll show you why I would recommend buying this coil as opposed to the other one. Okay. So this is the board. Why do I think buying this board opposed to the other one is better? And it's right here.
Okay.
That's 2 wire outside.
So that's our S1.
You got it.
S2.
So you could technically take this board, buy this coil. Somebody who has an AC only, you can convert them to a heat pump, use their Y and C wire outside for your S1, S2, and you don't have to run all those wires outside.
Beautiful.
So what do we got here? What does all this mean? Right? We have our 24 volt inputs. So you can see we have RC. You won't use L or any of that stuff. You have W1, W2, which should be hidden behind that piece right there.
Okay. Yep.
You have your B and O, your G, Y1, and the Y2/Y.
Okay.
Now those are your inputs, right? So from here to the left are all inputs. Over here, you're gonna have your outputs. You have your O, which just means out W2, out W1, out G. Out
And that
Y2.
would go out to the air conditioner.
No, this actually goes to your furnace.
Okay, into the furnace.
But that's a good question. So that's I think maybe, and technically, yes. Could it go to your air conditioner if you wanted to do a 24 volt setup? Sure.
But if you didn't, you could just go to your
yeah,
S1,
so you just
S2.
basically bring these terminals, you'll see up here, to your furnace. So what's also cool about this board? Well, first things first, you can still use 2 wire to the controller that it comes with. I don't have that controller with me, but you could do 2 wire to the controller. I'd prefer if you use the 24 volts. It'll be easier to integrate. All you do is just turn the SW1-1 dip switch on, just like before.
Okay.
So you turn that one on.
And that's for your 24?
Not me to turn that one on. Yep, so now you're in 24 volt mode, just thermostat communicating outside.
Okay.
And then if you're going to do full 24 volts, you just turn that one up.
Okay. So 4 and 1.
And I have a little breakdown sheet that shows all that too. But the other cool thing, like I said, is that S1, S2. So this plugs in right here to the first port. Don't plug it into the second one. And they are labeled right here. You can see we have refrigerant leak detection sensor 1 at CN8. And then we do not have a coil that has a second one, so don't worry about that. This is the T2 sensor. Plugs into the T2 slot. And then this is our T1 sensor, also known as our RAT sensor.
And there it
Return
goes.
our temp sense. Now we're done. So, to show you something pretty cool too, but the coolest thing I drew, which I can send to you, is this. That is really helpful, right? Because I broke it down by exactly what the board looks like. The problem with that other one is that's not what the board looks like.
Right? Yeah.
'Cause the furnace connections aren't at the top. This is actually what the board looks like.
Yeah.
So if we look at what this is just a diagram showing. So I drew on this, right? 24 volt standard inputs are here. And then you have R and C that come from your furnace.
Yeah.
And then you have your output terminals. You have the coil sensor that comes mounted on the coil.
Yeah.
You have the return air temp sense that plugs in here. You have HAHB if you do a communicating stat.
Yeah.
Refrigeration leak detector goes here. S1, S2. That's it. Dip switches. If this is down, you're using the communicating stat. If it's up, you're using a standard 24 stat. If this one's off, you're using S1, S2 for outdoor communicating. If it's on, you're using 24 volts. Right, I took the guts out of it, I jumped it out. So like you can turn on the heat, it's fully working. So you see your heat pump down there. Right now this is set up for the KJR, but turn it off. Go to mode, we can go to furnace, crank it up. We're in heating mode. And if you go to cooling mode, you can bring it down. And we'll go into cooling mode. So it's fully like ready to go. And we can also just jump it, right? We can also jump it from here. You can jump it from there. But it's fully installed and ready. I even wrote down what it is, right? This is the board that comes with it. This comes mounted from the factory. That's the A2L sensor. That's the extension cord. That's the return our temp sensor. But yeah, it's fully functioning. And like I said, they can bring it to their desk. Unit and the PAH 454B, both of them are in here.